concerned with graphs. So let's look here. Okay, so here, look at this. This column is just uniform motion. Okay, this column is uniform motion. What's happening to an object at uniform motion?
It's straight.
It's on cruise, right? Same speed.
Constant movement.
Yeah. Same speed or velocity. Okay, that's what's happening in uniform motion. So, on a dt graph, so whether it's distance or displacement, so this is going to count for distance or displacement. Okay? On a dt graph, what would uniform motion look like?
Straight across.
So if I, don't write this down, if I was straight across, it would mean that I'm at the same position for all of that time.
So you go to
It's like a 45 degree.
Yes, it would have to be at an angle. Okay? And this is hard because different graphs, it's hard to transition your brain. So for a VT graph, what would uniform motion look like? That one would be straight across.
Oh, so are we actually writing these ones down?
Yes, now these are the correct ones. Now Josh, not necessary. Okay. So do you see that these represent the same object moving? The object is moving at a uniform motion. The object is moving at a uniform motion. Okay?
What about AT?
Now we haven't done AT and we don't have to. AT graph for this one would actually be a flatliner because is this object accelerating?
Nope.
No. So its acceleration is 0. It's flatlined.
Oh yeah, sure.
Yeah. It's hard. Give yourself some. Okay. Now, please listen. This is very important. Uniform accelerated motion. What does an object look like on a dt graph that's accelerating? So we just did this one today.
Isn't it like really?
It goes up and then flat.
Like that, right? So that's accelerating. If it was a negative acceleration,
Does it have to have that little curve, or can it just be like?
it has to be curved. So what does a VT graph that's accelerating, what does that look like?
Like,
We just did that one.
It goes like
gosh, like.
Right?
So-
We just did that in our notes.
Which way would you be going? Down?
For which graph?
The VT.
Well, it could just be like north or east or west, but it's all going in the same direction.
That's how it like speeds up.
Do you think it's okay to start throwing stuff at him during class?
Okay. So what would an now we haven't done this and you don't have to know it, but then the acceleration would look like this because it is accelerating.
Like a straight line?
A straight line. Now, you only need to really know this one and this one.
Are we going to learn AT?
No.
Okay.
You only really need to know the first two rows. We'll do AT in Physics 20. So now, what we'll do is we'll say, what do we learn from slope for a DT graph and area, and what do we learn about slope and area for a VT graph to summarize everything we've done? Okay?
So should we make this like a chart?
Sure, if you like to organize it, you can make it a chart like this. If you like it to be a little bit more concise. Okay, so let's just first write down what slope is above. So when we find slope slope is where we go rise over run. Slope is rise over run. And area, if it's a rectangle, it's length times width. Or if it's a triangle, it's base times height divided by 2. So length times width, or base times height divided by 2. That's all we'll deal with graphs for area.
Base times.
Height divided by 2. Rise over run. I'm a little off center with the stop. Okay, so if we find the slope of a DT graph, so if we go delta D over delta T, that gives us V. Because D divided by T is a V. So when you find slope of a DT graph, you find V. Now, if it's displacement, you find velocity. If it's distance, you find speed. A what?
Line.
Above it? If it's velocity, but I'm just doing a generalized. We don't do anything for area with DT graphs.
So is that one also the y2 minus y1?
Yeah, so if you want to put here, you can put 2, slope is y2 minus y1 divided by x2 minus x1. That's what slope is too, right? Rise over run.
So there's no area in a VT graph, or in
In a DT graph, we don't do any area. Okay, now in a VT graph, the slope, so when we go delta V over delta T, because we're looking at the change in velocity over a change in time, what is V divided by T on your formula sheet? A. So when you find slope of a VT graph, you find A,
Which is acceleration.
which is acceleration.
Does that mean that it has to be like velocity or something?
Yes.
So it has a little thing?
Yeah.
Doesn't acceleration have an arrow over it though?
Yes, and okay. I'm just trying to be general so that it can apply to either speed, but you're right, for acceleration, it has to be a vector. You guys are right. Okay, so if I find an area for a VT graph, whether I have to do it a triangle or not, I multiply delta V times T. If it's a triangle, you have to divide that by 2. But if you're multiplying those two things together, what does that have to equal? Displacement. Now, if it's a speed, you could also have delta V times T equals distance. So either speed time or velocity time. And here too, we can add that in here. So we had written, I'm just going to move it up a bit. We had written delta D over delta T is equal to V. Or we could have delta D with the arrow over delta T is equal to V with the arrow. Okay. So that's what you need to know. And we won't do area or slope for those ones. Now tomorrow on your test, there is one where you have to calculate slope and do stuff, but I tell you to find this, you need to find slope, okay? So I give you I give you major hints so that you don't get mixed up with which one you have to do. Okay? And so I'll help you.